Hello, this is Brian Southworth. Welcome to this video on modeling with variation. So there's several types of variation. First one we'll talk about is what's called direct variation. Direct variation kind of in application deals with the idea of if you have two different quantities, as one increases, the other one's also going to increase. For example, the more hamburgers you buy, the more money you're going to spend, that type of thing. So y varies directly with x, or y is directly proportional to x means y equals k times x. Now, the k here is if your proportionality is not 1-to-1. So 1-to-1 means if I buy one hamburger, I spend, say, $1. If I buy two, I spend $2. Well, that's not always going to be true, right? Think about buying gas. I think right now where I live currently at this time is $2 a gallon. So if I buy 1 gallon, I spend $2. Well, if I buy 2 gallons, I spend 4. So the two quantities aren't growing at the same rate. And the k is called a constant of proportionality. I sometimes like to just simplify it to the COP or the COP. Okay. Solving variation problems, doesn't matter what kind of variation you're doing, it's basically the same 4 steps every time. So first thing, identify the type of variation. Or it could be variations. You can mix and match sometimes. Solve for the constant proportionality, the COP. Substitute the value of k into the equation from step 1. And finally use that to answer the question. So here we are. An alligator's tail length t varies directly with its body length b. An alligator with a body length of 4 has a tail length of 3.6 feet. What is the tail length of the alligator? Okay. So usually this breaks down to 3 cases. So step 1 is, right, identify the type of variation. So you're usually looking for words like inverse or mixed, combined, or direct. So that'll almost always be this first sentence right there. Now, in the formula up here, it's y equals kx. So sometimes people get a little confused on who goes where. Well, when you read it, y varies directly or y varies proportionally. So whatever comes first before the words varies directly or varies proportionally or varies inversely, whatever you're using, is by itself. So in our case, tail length comes first. So t equals k. You always have k, no matter what type of variation you have, k will always be there. For direct variation, you're always going to multiply, so k times the other quantity, b. So that's our original equation. Now, I need to find what k is. How much is k equal? What is its value? So key for this is, this equation right here has 1, 2, 3 unknowns. If I need to find k, that means I need an equation or something that gives me a t and a b at the same time. Generally, that's going to be the second sentence or the first sentence. So in our case, right, an alligator with a body length of 4 has a tail length of 3.6 feet. So the second sentence right here. So body length is 4. Tail length is 3.6. Okay. So we're going to plug this information right here into that. So T is 3.6 equals K times 4. Or divided by 4s, K equals 3.6 over 4 or 0.9. So step 3 combines the original, so T equals KB over here, and K, which is 0.9. So our new equation is going to be T equals 0.9 B. Finally, we're ready to answer the question. Step 4 is use the equation to answer the question. So our question, usually the last sentence or the last part of the second sentence, in this case, the last sentence, is here. What is the tail length of an alligator whose body is 4? So we're asking T equals what if B equals 6? So T equals 0.9 from the formula over here times 6. So it's going to be 5.4. And again, we're doing in feet, right? This is 6 feet. So it's going to be 5.4 feet. So there's our answer. Now, if you want to be clear, that means the alligator, tail's body is 6 feet long, and the tail is 5.4 feet long. So it's almost 11.5 feet long alligator. So that's a pretty big guy. All right, let's talk about the next type of variation. And just as a reminder, direct says, since it's moved up, y equals k times x. So inverse variation, y varies inversely with x, y is inversely proportional. This usually means that one idea is going up and the other one is going down. A simple one for this is, it's not true for all cars, but in general, as your car gets older, its value decreases. Right? The deeper you go in the water, the colder the water is. Right? As the depth increases, the temperature decreases, but something like that. Now, for direct, one goes up, the other goes up. You multiply, right? You're multiplying right here. For inverse, one goes up, the other one goes down. So again, for all variation, you have a k. It's just what you do with that k. So I got my k. Because it's inverse, we're going to divide by x. So inverse means you take your k and divide. Direct means you take your k and multiply. Let's see what we have. The water temperature of the Pacific Ocean varies inversely as the water's depth. At a depth of 1,000 meters, the water temperature is 4.4 degrees Celsius. What is the temperature at a depth of 5,000 meters? Well, first, first sentence says temp, inversely, and depth. So those are the things, right? Temperature comes before the words inversely or varies. So temperature, we'll call it T, equals K Varies inversely means the depth is going to be on the bottom. We'll call that D. So there we are. T is K over D. Now, trying to find K, have three variables, K, T, K, and D. To find K, I need a T and a D that go together. So at depth of 1,000 meters, the water temperature is 4.4 Celsius. So here we are. So D is 1,000. T is 4.4 degrees Celsius. Go plug that into our equation. So 4.4 degrees equals K over 1,000. To get rid of our fraction, we're going to go ahead and multiply by 1,000. So 4.4 times 1,000 equals K over 1,000 times 1,000. So on the right side, 1,000s divide, you get K. 4.4 times 1,000 is 4,400. So our new equation is T equals K over D. K is now 4,400. Over D. Now we're finally ready to answer the last question. Use that last sentence. So, what is the temperature at depth of 5,000? So, if D equals 5,000, T equals question mark. Well, take our equation. T equals 4,400 divided by 5,000. If we reduce this immediately to just being 4,450, this makes us 0.88 degrees Celsius. So 5,000 meters, which is roughly 3 miles, water's almost freezing. Some people might ask, well, why do we care about this? Well, when you're creating submersibles, either for exploration, for scientific knowledge, or exploration for oil, or maintenance of oil rigs who are actually drilling off coast in deep waters, you have to know what the temperature is going to be and the pressure and so forth to build a $1 million worth of equipment that can go down to the bottom of the ocean and not be destroyed. So it's very important for very specific fields. So. All right, then there's what's called combined variation. Combined variation just means you can put direct and inverse into the same equation. When you mix them up, you still only have one K. Direct means you multiply K, inverse means you divide K. So let's take a look. Body mass index, or BMI, varies directly as one's weight in pounds and inversely as the square of one's height in inches. So BMI, I'm just gonna call that B. P equals K. And then, right, directly as one's weight, so K times W, over, or inversely as the square of one's height. So it's the square of height. So over h squared. That's it. Now when I find K, I have four variables, B, K, W, and H. In order to find K, I need a sentence that has a B, a W, and an H. So a person who weighs 180 pounds and is 5 feet or 60 inches tall, remember, weight, heights in inches, that's important, has a BMI of 35.15. So what do we have? Weight is 180. H is 60. B, 35.15. So putting those in, 35.15 equals K times 180 over 60 squared. So I'm going to do some quick calculations. Here, get your calculator out. 180 divided by 60, try not 60, by 360 squared. So 180 divided by 60 squared is 0.5. Divide everything by 5, sorry, 0.05. So 35.15 divided by 5.05, 703. So our new equation is B equals 703 times W over H squared. Okay. Oh, excuse me. And then finally, we're going to answer the question. What is the BMI, it's the nearest tenth, of a person who's 170 pounds and 5 foot 10 inches? So P equals what if weight equals 180 and height is 5 foot 10 inches. Remember, how tall is 5 feet? In our text right here, remember, it says so it's 5 foot is 60 inches. So in that case, H is going to be 60 plus 10, or H is 70. Once we do that, I'm ready to plug this up into my equation. So B equals 703 times 180 over 70 squared. Put your calculator to work. We get 25.82, which is run to, since the nearest 10th, we're at 25.8. All right. And the last one, last type of variation is called joint variation. Joint variation works with two more variables. Basically, it's direct variation with multiple variables. So, y varies. This spot here says directly as x and z. So, the heat loss of a glass window varies jointly as the window's area and the difference between its inside temperature and the outside temperature. A window 3 feet wide by 6 feet long loses 1200 BTU per hour, and the temperature outside is 20 degrees colder than the temperature inside. The heat loss through the glass, find the heat loss through the glass window that is 6 feet wide and 9 feet long, when the temperature outside is 10 degrees colder than the temperature inside. Okay. So, if heat loss varies jointly with area and temperature difference. So we'll just call it L for loss. We'll put K here. Again, doesn't matter what kind of variation you get, always get the K. If it's joint, multiply everything to it. So as the area, so capital A times the temperature difference. I'm just call it temperature. Now I need to find K. So I need something that gives me area, temperature difference, and heat loss. So what do we got? We have windows 3 feet by 6 feet long. It loses 1200 BTU per hour. Again, the BTU is the British thermal unit. As if it was in the metric system, it would be considered a calorie. And the temperature, difference in temperature is 20 degrees cooler inside versus outside. So first thing, area, a rectangle window is going to be length times width. So we're told 3 feet wide by 6 feet long. So 6 by 3 equals 18. L is 1200 BTU, and the difference in temperatures is 20 degrees. So let's plug it into our formula now. 1200 equals K times 18 times 20. All right. So 1200 equals 360 K. So divided by 360, you're going to get get a fraction looks like. So I have 120 over 36. 6 goes in these both, so we're going to get 20 over 6, or 10 over 3. K is 10 over 3. So our new formula will be L equals 10 over 3 times A and T. Finally, we're ready to answer the question. So find the heat loss through a glass window that is 6 feet wide by 9 feet long, and temperature difference is 10 degrees. So else question mark if area linked by width will be 6 by 9, 54, and temperature is 10. So L equals 10 thirds times 54 times 10. 3 goes into 54 18 times. So you have 10 times 18 times 100, 10. So 100 times 18 makes this 1800 BTU. There you are. Again, when doing this, identify a type of variation. So it'll be something varies directly or inversely, or some sort of mixed group. Whatever comes first goes in front of the K, goes in front of the K. So if something equals K, then with K, if you multiply directly, so multiply K if it's directly, divide K, divide into K if inversely. Okay, let me know if you have any questions.